we are talking about how to design graphs. Graphs are very good for storing and processing data with complex relationships, such as self-referencing, hierarchical, or many-to-many relationships. At a high level, when we do graph design, we do denormalization. In other words, we allow data redundancy, but we still want to know the data usage pattern of a specific scenario so that we can design the best graph for that scenario. By the way, graphs consist of vertices and edges. Vertices are entities, or the real-world objects. Edges are relationships. Relationships describe how vertices are related to each other. We want to be familiar with these commonly used properties for vertices and edges. When we do the entity relationship modeling for graphs, generally speaking, we want to map an entity to a vertex, and we use the property-embedded vertices technique. In other words, we do denormalization. This gives us better performance, simpler queries, and a scalable graph database. But again, we want to pay attention to the data usage pattern so that we can create the best model for a specific scenario. Keep in mind, edges describe how vertices are related to each other. When we design edges, we want to use the default outgoing direction whenever possible, because vertices are stored with their outgoing edges. Therefore, if we use the default outgoing direction, we can get the best performance. Also, pay attention to how we label edges. We want to make sure the edge labels are highly selective. This will make the operations a lot more efficient. Here is an example of using the distinct edge labels. Distinct edge labels can improve the graph traversal. When we design a graph database, just like designing any other NoSQL database, we do partitioning a lot. If we use the Azure Greenland Graph database, both vertices and edges are stored as JSON documents. And keep in mind, edges will be stored with their source vertices. Here are some best practices when we do graph partitioning. We want to make sure we select a partition key or a sharding key that will evenly distribute data across all available partitions. Also, when we traverse a graph, we want to write queries that will possibly get the data from a single partition. It will greatly improve the traversal performance. This concludes our brief discussion.